The universe is vast, mysterious, and filled with secrets that defy our understanding. Picture this, a force so powerful it bends the fabric of space and time, yet we can't see it, touch it, or even fully explain it. This isn't science fiction, it's the reality of the cosmos we live in. From invisible matter pulling galaxies apart to signals from deep space that vanish as quickly as they appear, the universe is a puzzle with pieces we're still trying to fit together. In this video, we're diving into 25 cosmic phenomena that even the brightest minds on Earth can't fully explain. These aren't just curiosities, they're mysteries that challenge everything we think we know about space, time, and reality itself. So, if you've ever looked up at the night sky and wondered what's really out there, you're in the right place. By the end of this journey, you'll see the universe in a whole new light and maybe even question what's possible. Let's begin. Now, let's turn our attention to one of the most baffling mysteries in the cosmos: dark matter. Imagine a substance that makes up roughly 27% of the universe, yet it's completely invisible. We can't see it, touch it, or even detect it directly with any of our current technology. So, how do we know it's there? The answer lies in its gravitational effects. Dark matter's presence is felt through the way it tugs on galaxies, bending light and influencing their movements in ways that ordinary matter simply can't explain. Without dark matter, galaxies would fly apart, unable to hold their shape. But despite its undeniable influence, dark matter remains elusive. Scientists have been searching for decades, using everything from underground detectors to space-based telescopes, hoping to catch a glimpse of this mysterious substance. Yet so far, it's managed to stay hidden, leaving us with more questions than answers. What is it made of? How does it interact with the rest of the universe? These are the puzzles that keep researchers up at night. And until we find direct evidence, dark matter will remain one of the greatest enigmas of the cosmos. Now, shifting our gaze to another cosmic puzzle, let's dive into the enigmatic force known as dark energy. While dark matter pulls galaxies together, dark energy does something entirely different. It pushes the universe apart. In fact, it's believed to be the driving force behind the accelerated expansion of the cosmos. Imagine the universe as a balloon, constantly inflating faster and faster, with dark energy as the mysterious hand that keeps blowing air into it. This discovery, made in the late 1990s, completely upended our understanding of the universe. Before then, scientists thought the expansion might slow down over time due to gravity. But instead, they found that galaxies are moving away from each other at an ever-increasing speed. So, what exactly is dark energy? The truth is, we don't know. It's invisible, doesn't interact with light, and can't be detected directly. Yet, it makes up about 68% of the universe, dwarfing even dark matter in its influence. Some theories suggest it's a property of space itself, a kind of energy woven into the fabric of the cosmos. Others propose it could be a new kind of field or force, something entirely beyond our current understanding of physics. What makes dark energy so perplexing is that it challenges the very foundations of Einstein's theory of relativity and our understanding of how the universe works. Despite decades of research, dark energy remains one of the greatest mysteries in science. Why does it exist? How does it work? And what does it mean for the future of the universe? These questions keep scientists on the edge of their seats as they continue to search for clues through observations of distant supernova, galaxy clusters, and the cosmic microwave background. Until we uncover more, dark energy will remain a tantalizing reminder of just how much we still have to learn about the cosmos. And speaking of cosmic mysteries, let's move on to another gravitational enigma, the Great Attractor, a mysterious force pulling galaxies toward it in a way that defies explanation. Now, let's turn our attention to a gravitational mystery that's been pulling galaxies and scientists' curiosity toward it for decades. meet the Great Attractor, a colossal gravitational anomaly located roughly 250 million light-years away from Earth. This invisible force is so powerful that it's dragging entire galaxies, including our own Milky Way, toward it at speeds of over 600 kilometers per second. But here's the catch: we can't see it. The Great Attractor lies in a region of space known as the zone of avoidance, an area obscured by the dense dust and stars of our own galaxy's disk. This makes it incredibly difficult to observe directly, as the light from objects behind it is blocked by the Milky Way. Imagine trying to look through a thick fog. That's the challenge astronomers face when studying this cosmic enigma. What makes the Great Attractor even more intriguing is that it's not just pulling galaxies toward it, it's part of an even larger structure. Scientists believe it sits at the heart of the Laniakea supercluster, a vast network of galaxies spanning over 500 million light-years. This supercluster is like a cosmic web, with the Great Attractor acting as one of its most significant gravitational anchors. But what exactly is the Great Attractor? Is it a massive cluster of galaxies, a supermassive black hole, or something entirely different? The truth is, we're still not sure. Some theories suggest it could be a dense concentration of dark matter, while others propose it might be the result of a cosmic collision or merger. What we do know is that its gravitational pull is reshaping the motion of galaxies on an enormous scale, challenging our understanding of how the universe is structured. Studying the Great Attractor is like trying to solve a puzzle with half the pieces missing. Astronomers rely on indirect methods, such as mapping the motion of galaxies and using infrared and radio telescopes to peer through the zone of avoidance. Each new observation brings us closer to unraveling this mystery, but for now, the Great Attractor remains a powerful reminder of how much we still have to learn about the forces shaping our universe. And as we continue our journey through the cosmos, let's shift our focus to another fleeting yet fascinating phenomenon: fast radio bursts, those mysterious signals from deep space that appear and disappear in the blink of an eye. Now, let's dive into one of the most fleeting and enigmatic phenomena in the cosmos: fast radio bursts, or FRB. These are incredibly brief but intensely powerful bursts of radio waves that originate from deep space, often lasting just milliseconds. Despite their short duration, they release as much energy as the sun does in an entire day. What makes FRBs so fascinating is their unpredictability. They appear suddenly, without warning, and vanish just as quickly, leaving astronomers scrambling to catch and study them. The first FRB was detected in 2007, and since then hundreds have been observed. Some repeat, sending out multiple bursts over time, while others are one-off events, making them even harder to study. The sources of these bursts are located billions of light-years away, meaning they've traveled across vast stretches of the universe to reach us. But what could possibly produce such a sudden and immense release of energy? Scientists have proposed several theories to explain the origins of FRBs. One leading idea is that they come from highly magnetized neutron stars known as magnetars. These dense, rapidly spinning stellar remnants are capable of producing enormous magnetic fields, which could generate the intense bursts of radio waves we detect. Another possibility is that FRBs are the result of cataclysmic events, such as the collision of neutron stars or the collapse of a massive star into a black hole. But of course, there's always the tantalizing question: could FRBs be signals from an advanced alien civilization? While this idea captures the imagination, most scientists lean toward natural explanations, given the sheer energy and distance involved. Still, the possibility can't be entirely ruled out, and it adds an extra layer of intrigue to these cosmic signals. The challenge with FRBs lies in their fleeting nature. Catching one in action requires precise timing and a bit of luck. Astronomers use radio telescopes to monitor the skies, hoping to catch a burst as it happens. When they do, they can trace its origin and study its properties, piecing together clues about what might have caused it. Each new detection brings us closer to understanding these mysterious signals, but for now, FRBs remain one of the most puzzling phenomena in the universe. They remind us that even in the vastness of space, there are still events that defy our expectations and challenge our understanding of the cosmos. And as we continue to explore the mysteries of the universe, let's turn our attention to another profound question. Why, in a cosmos so vast and filled with possibilities, have we yet to find evidence of extraterrestrial life? This brings us to the Fermi Paradox, a mystery that has puzzled scientists and thinkers for decades. Now, shifting our gaze from the fleeting bursts of cosmic energy, we arrive at one of the most profound questions in astronomy, the Fermi Paradox. Named after the physicist Enrico Fermi, this paradox highlights a puzzling contradiction. The universe is unimaginably vast with billions of galaxies, each containing billions of stars and planets. Statistically, the odds of life existing elsewhere seem almost certain. Yet, despite decades of searching, we've found no concrete evidence of extraterrestrial civilizations. So, where is everyone? One possible explanation is that life, especially intelligent life, might be far rarer than we think. While the universe is teeming with planets, the conditions necessary for life to emerge and evolve could be incredibly specific. Earth's unique combination of a stable star, a protective atmosphere, and just the right chemical ingredients might be a cosmic fluke. Even if life does arise elsewhere, it might not progress to the point of developing advanced technology or communication methods. Another angle to consider is the limitations of our own technology. The universe is not only vast but also ancient. Civilizations could have risen and fallen billions of years before humans even existed, leaving behind no detectable traces. Or they might be using forms of communication or technology that we simply can't detect or understand yet. Imagine trying to spot a campfire on a distant planet with a telescope. It's not impossible, but it's incredibly difficult with our current tools. Some scientists propose that advanced civilizations might self-destruct before they can make contact with others. Whether through war, environmental collapse, or other catastrophic events, the window for communication might be tragically short. Others suggest that intelligent life might choose to remain hidden, avoiding contact with less advanced species to prevent interference or conflict. Then there's the idea that we might be looking in the wrong places. The universe is so vast that even if civilizations are out there, they could be too far away for us to detect their signals. Or they might be located in regions of space we haven't yet explored. Our search for extraterrestrial life is still in its infancy, and we've only scratched the surface of what's possible. The Fermi Paradox doesn't just challenge our understanding of life in the universe, it forces us to confront the limits of our knowledge and imagination. It's a reminder that, despite our technological advancements, we're still just beginning to explore the cosmos. And as we continue to search for answers, we're left with more questions than ever before. With this mystery still lingering, let's turn our attention to another intriguing cosmic signal, one that has baffled scientists for decades. This brings us to the WOW signal, a brief but powerful radio burst that has never been fully explained. Now, let's dive into one of the most tantalizing mysteries in the search for extraterrestrial intelligence, the WOW signal. Detected on August 15, 1977, this powerful radio burst lasted for 72 seconds and came from the direction of the constellation Sagittarius. It was so remarkable that the astronomer who discovered it, Jerry Amon, circled the data on the printout and wrote WOW next to it, a name that has stuck ever since. The WOW signal was picked up by the Big Ear radio telescope at Ohio State University, which was scanning the skies for signs of extraterrestrial communication. What made this signal stand out was its intensity and frequency. It was concentrated at a frequency of 1,420 MHz, a range that's often considered ideal for interstellar communication because it's relatively free of interference from natural cosmic sources. This frequency is also close to the hydrogen line, a key marker in radio astronomy, which some believe could be a deliberate choice by an advanced civilization trying to get our attention. Despite its strength and specificity, the WOW signal has never been detected again, despite numerous attempts to find it. This one-time nature has only deepened the mystery. If it was a message from an alien civilization, why hasn't it been repeated? And if it wasn't, what could have caused such a powerful, focused burst of radio waves? One possibility is that the signal came from a natural cosmic event, such as a comet or a distant star. However, no known natural phenomenon matches the characteristics of the WOW signal. Comets, for example, emit radio waves, but they're usually much weaker and more diffuse. Stars and other celestial objects also don't produce signals that align so perfectly with the hydrogen line frequency. Another theory is that the signal was indeed artificial, perhaps a one-time transmission from an alien civilization. If that's the case, it raises even more questions. Was it a deliberate attempt to communicate or just a stray signal from a distant technology? And if it was intentional, why hasn't there been any follow-up? Some speculate that the civilization might have been testing their equipment or sending a brief signal before moving on to other projects. The WOW signal remains one of the strongest candidates for evidence of extraterrestrial intelligence, but without further data, it's impossible to say for sure. It's a reminder of how much we still don't know about the universe and the potential for life beyond Earth. Every unexplained signal, every mysterious burst of energy brings us one step closer to answering the ultimate question: are we alone? As we ponder the possibilities of the WOW signal, let's turn our attention to another cosmic oddity that has sparked both scientific curiosity and wild speculation: Tabby Star, a celestial object whose strange behavior has led some to wonder if it's home to alien megastructures. Now, let's shift our gaze to a star that has baffled astronomers and sparked imaginations worldwide: Tabby Star, also known as KIC 8462852. Located roughly 1,400 light-years away in the constellation Cygnus, this star has become famous for its bizarre and unpredictable dimming patterns. Unlike most stars which dim in regular, predictable cycles, Tabby Star experiences sudden and dramatic drops in brightness, sometimes by as much as 22%. These dips are irregular, lasting anywhere from days to weeks, and they don't follow any obvious pattern. This strange behavior has led to some truly out-of-this-world theories, including the possibility of alien megastructures. The idea of alien megastructures comes from the concept of a Dyson sphere, a hypothetical structure built by an advanced civilization to harness the energy of a star. Some scientists have speculated that the irregular dimming of Tabby Star could be caused by such a structure, perhaps partially completed or in the process of being built. The idea is fascinating, but it's important to note that this is just one of many possible explanations. While the thought of an alien megastructure is thrilling, scientists have also proposed more natural causes for the star's unusual behavior. One leading theory is that the dimming could be caused by massive clouds of dust and debris orbiting the star. These clouds could be the remnants of a planetary collision or the result of a swarm of comets passing in front of the star. Dust clouds are known to scatter and absorb light, which could explain the irregular dips in brightness. Another possibility is that the star itself is undergoing internal changes, such as fluctuations in its magnetic field or unusual stellar activity, though these explanations don't fully account for the extreme dimming observed. What makes Tabby Star even more intriguing is that it doesn't fit neatly into any known category of variable stars. Most stars that dim do so because of orbiting planets or companion stars, but Tabby Star doesn't show the consistent patterns associated with these phenomena. This has left astronomers scratching their heads and searching for new ways to explain what's happening. Observations from telescopes like Kepler and Hubble have provided valuable data, but the mystery remains unsolved. The debate over Tabby Star highlights the challenges of studying distant objects in the universe. Even with advanced technology, we're often left with more questions than answers. Whether the dimming is caused by alien megastructures, dust clouds, or something entirely unexpected, Tabby Star reminds us that the universe is full of surprises. As we continue to study this enigmatic star, we may uncover new insights not just about Tabby Star, but about the nature of stars and planetary systems across the cosmos. With this cosmic puzzle still unresolved, let's turn our attention to another mystery closer to home: the Pioneer Anomaly, an unexpected behavior of spacecraft that has puzzled scientists for decades. Now, let's journey closer to home and explore a mystery that has puzzled scientists for decades: the Pioneer Anomaly. Back in the 1970s and 80s, as the Pioneer 10 and Pioneer 11 spacecraft ventured beyond the outer planets, something strange happened. These spacecraft, which were designed to study Jupiter, Saturn, and the outer reaches of our solar system, began to slow down in a way that no one could explain. According to the laws of physics, their speed should have remained constant as they traveled farther from the Sun, but instead they experienced a tiny but consistent deceleration. This unexpected behavior became known as the Pioneer Anomaly, and it left scientists scratching their heads for years. At first, the deceleration was so slight that it seemed almost negligible, just a fraction of a nanometer per second squared. But over time, this tiny effect added up, causing the spacecraft to drift off their predicted trajectories. The anomaly was so perplexing that it sparked a wide range of theories, from the mundane to the extraordinary. One of the leading explanations focused on thermal radiation. The spacecraft were powered by radioactive plutonium, which generated heat. Scientists speculated that this heat might have been radiating unevenly from the spacecraft, creating a tiny but measurable push in the opposite direction of their motion. This could have acted like a subtle brake, slowing them down over time. However, not everyone was convinced by the thermal radiation explanation. Some researchers proposed that the Pioneer Anomaly might be evidence of new physics, something beyond our current understanding of gravity and motion. Could there be an unknown force at play in the outer solar system? Or perhaps our understanding of gravity itself needed to be revised? These questions open the door to fascinating possibilities, including the idea that dark matter or other unseen forces might be influencing the spacecraft's motion. While these theories were intriguing, they also raised more questions than answers. In the end, after years of analysis and debate, the most widely accepted explanation turned out to be a combination of factors, with thermal radiation playing a significant role. Detailed studies of the spacecraft's design and heat distribution showed that the uneven radiation could indeed account for most, if not all, of the observed deceleration. While this explanation may not be as exciting as the idea of new physics, it highlights the importance of meticulous observation and the need to consider all possibilities when solving cosmic mysteries. The Pioneer Anomaly serves as a reminder that even in our own solar system, there are still phenomena that challenge our understanding. It also underscores the incredible precision required to study the universe and the lengths scientists go to uncover the truth. As we continue to explore the cosmos, anomalies like this remind us that there's always more to learn, and that sometimes the answers lie in the details we might initially overlook. With this mystery now largely resolved, let's turn our attention to an even more enigmatic visitor from beyond our solar system: the Oumuamua object, the first known interstellar traveler to pass through our cosmic neighborhood. Now, shifting our gaze to a visitor from beyond our solar system, we encounter one of the most intriguing cosmic mysteries of recent years: the Oumuamua object. In October 2017, astronomers detected something extraordinary: a small, fast-moving object hurtling through our solar system. What made this discovery so remarkable was that Oumuamua, as it came to be known, was the first confirmed interstellar object ever observed passing through our cosmic neighborhood. Unlike the countless asteroids and comets that originate within our solar system, Oumuamua came from somewhere far beyond, making it a true cosmic wanderer. From the moment it was spotted, Oumuamua stood out for its unusual characteristics. For starters, its shape was unlike anything we've seen before. Most asteroids and comets are roughly spherical or irregularly shaped, but Oumuamua appeared to be elongated, resembling a cigar or a pancake. Estimates suggested it could be up to 10 times longer than it was wide, a shape that defied expectations and sparked endless speculation. How did it form? What processes could create such a bizarre structure? These questions only deepened the mystery, but the surprises didn't end there. As Oumuamua traveled through our solar system, astronomers noticed something even more puzzling. It was accelerating. Objects in space typically follow predictable paths dictated by gravity, but Oumuamua seemed to be speeding up slightly as it moved away from the sun. This unexpected behavior led to a flurry of theories. Some scientists suggested it might be a comet, with outgassing, the release of gas and dust causing the acceleration. However, no visible coma or tail, the usual signs of a comet, were detected. Others proposed it could be an asteroid, but its acceleration didn't fit that explanation either. The lack of a clear explanation fueled even more imaginative ideas. Some researchers speculated that Oumuamua might be something entirely different, perhaps a fragment of a shattered planet, a chunk of hydrogen ice, or even an artificial object like a probe sent by an extraterrestrial civilization. While the latter idea captured the public's imagination, most scientists remained skeptical, emphasizing the need for natural explanations. Still, the possibility of Oumuamua being something other than a typical asteroid or comet kept the debate alive. One of the most compelling theories suggests that Oumuamua could be a type of cosmic iceberg, made up of exotic materials like molecular hydrogen or nitrogen ice. These materials could sublimate, turn directly from solid to gas, when exposed to sunlight, creating the observed acceleration without producing a visible tail. This idea aligns with some of the observations but still leaves many questions unanswered. What's clear is that Oumuamua represents a new class of interstellar objects, challenging our understanding of how such bodies form and behave. As Oumuamua sped away from our solar system, it left behind more questions than answers. Its brief visit reminded us that the universe is full of surprises, and even objects from distant star systems can hold secrets that push the boundaries of our knowledge. While we may never fully understand Oumuamua's true nature, its discovery has opened the door to a new era of interstellar exploration, inspiring scientists to keep searching for more visitors from the stars. With this cosmic enigma still fresh in our minds, let's turn our attention to another profound mystery that lies at the heart of black holes. The black hole information paradox, a puzzle that challenges the very foundations of physics. Now, as we venture deeper into the cosmos, we encounter a mystery that strikes at the very heart of our understanding of physics, the black hole information paradox. This paradox arises from a fundamental conflict between two of the most successful theories in science, quantum mechanics and general relativity. At its core, the paradox questions what happens to information when it falls into a black hole. According to quantum mechanics, information cannot be destroyed. It must be preserved in some form. But black holes, as described by general relativity, are regions of space-time where gravity is so intense that nothing, not even light, can escape. So, what happens to the information carried by matter that crosses a black hole's event horizon? Does it vanish forever, or is it somehow retained? This question first gained prominence in the 1970s when Stephen Hawking made a groundbreaking discovery: black holes aren't entirely black. Through a process now known as Hawking radiation, black holes slowly emit energy and lose mass over time, eventually evaporating completely. This revelation was revolutionary, but it also introduced a problem. If a black hole evaporates, what happens to all the information about the matter that fell into it? Hawking initially suggested that the information is lost forever, effectively erased from the universe. This idea, however, directly contradicts the principles of quantum mechanics, which state that information must always be conserved. This contradiction became known as the black hole information paradox, and it has puzzled physicists for decades. Over the years, scientists have proposed various theories to resolve this paradox. One leading idea is that the information isn't truly lost, but is instead encoded in the Hawking radiation itself. This would mean that, as a black hole radiates, it somehow imprints the information about the matter it consumed onto the escaping particles. However, this raises another question. How does the information escape the black hole's intense gravitational grip? Some theories suggest that the event horizon, the boundary of a black hole, might not be as impenetrable as we once thought. Others propose that the information is stored in a mysterious structure called a firewall, a hypothetical barrier of energy at the event horizon that could scramble and release the information. Another intriguing possibility is that black holes don't completely evaporate. Instead, they might leave behind a tiny remnant, a quantum hair, that contains all the information about the matter that fell into the black hole. This idea aligns with the concept of holography, which suggests that all the information about a three-dimensional space can be encoded on a two-dimensional surface, like the event horizon of a black hole. While these theories offer potential solutions, none have been conclusively proven, and the paradox remains one of the most hotly debated topics in theoretical physics. Stephen Hawking himself revisited the paradox later in his career, proposing that information might escape through quantum fluctuations at the event horizon. This idea, while not fully resolving the paradox, opened new avenues for research and inspired a generation of physicists to tackle the problem. Today, the quest to solve the black hole information paradox continues, with experiments and observations aimed at uncovering the true nature of black holes and their mysterious behavior. As we grapple with this profound mystery, it's clear that black holes are more than just cosmic vacuum cleaners. They are laboratories for testing the limits of our understanding. The black hole information paradox challenges us to rethink the very fabric of reality, pushing the boundaries of physics and inspiring new theories that could one day revolutionize our view of the universe. With this enigma still unresolved, let's turn our attention to another cosmic oddity that defies explanation: the axis of evil, a peculiar alignment in the cosmic microwave background that has left scientists scratching their heads. Now, shifting our gaze to the very fabric of the universe itself, we encounter a cosmic anomaly so perplexing that it's been dubbed the axis of evil. This mysterious feature isn't a malevolent force, but rather an unexpected pattern found in the cosmic microwave background radiation, the faint afterglow of the Big Bang. Discovered in the early 2000s, this alignment has left scientists questioning some of the fundamental assumptions about the origins and structure of our universe. The cosmic microwave background, or CMB, is essentially a snapshot of the universe when it was just 380,000 years old. It's a treasure trove of information, revealing the seeds of galaxies, clusters, and the large-scale structure we see today. But when researchers analyzed the CMB, they noticed something strange. Certain temperature fluctuations appeared to align along a specific axis, creating a pattern that defies the standard model of cosmology. According to the Big Bang theory, the universe should be isotropic, meaning it should look the same in all directions. Yet, the axis of evil suggests a preferred direction, challenging this foundational principle. This discovery has sparked intense debate among cosmologists. Some argue that the alignment could be a statistical fluke, a quirk of the data that doesn't hold deeper significance. Others, however, see it as a potential crack in our understanding of the universe. If the axis of evil is real, it could imply that the Big Bang wasn't as uniform as we thought, or that there's some larger structure or force at play that we haven't yet accounted for. Could it be evidence of a multiverse where our universe is just one of many, each with its own unique properties, or does it hint at new physics beyond our current theories? One of the most intriguing possibilities is that the axis of evil might be linked to dark energy, the mysterious force driving the accelerated expansion of the universe. Some researchers speculate that dark energy could have imprinted this alignment on the CMB, leaving behind a cosmic fingerprint that we're only now beginning to decipher. Alternatively, the alignment might be a remnant of an earlier phase of the universe, a relic from a time before the Big Bang itself. These ideas, while speculative, highlight just how much we still have to learn about the cosmos. Despite decades of study, the axis of evil remains an unsolved mystery. It serves as a reminder that even our most well-established theories, like the Big Bang, are not immune to scrutiny. As scientists continue to analyze the CMB with ever greater precision, they hope to uncover clues that will either confirm or refute this enigmatic alignment. For now, the axis of evil stands as one of the most tantalizing puzzles in cosmology, challenging us to rethink our place in the universe and the forces that shaped it. With this cosmic conundrum still lingering, let's turn our attention to another mystery that has baffled astronomers for years, the missing baryon problem, which asks the question, where is all the ordinary matter in the universe hiding? Now, as we venture deeper into the cosmic unknown, we stumble upon a mystery that's as puzzling as it is fundamental, the missing baryon problem. You might think that after centuries of studying the universe, we'd have a pretty good handle on where all the ordinary matter is. After all, this is the stuff that makes up everything we can see: stars, planets, galaxies, and even you and me. But here's the twist: when scientists tally up all the ordinary matter, or baryons, predicted by the Big Bang theory, they find that a significant chunk of it is simply missing. So, where is it hiding? To understand the scale of this mystery, let's break it down. According to our best models, ordinary matter should make up about 5% of the universe's total mass and energy. But when astronomers look around, they only find about half of that amount. The rest seems to have vanished without a trace. This isn't dark matter or dark energy we're talking about. This is the stuff we're made of, the atoms and molecules that form the building blocks of the cosmos. So how could so much of it just disappear? One leading theory is that the missing baryons are hiding in the vast, diffuse regions of space between galaxies. These areas, known as the intergalactic medium, are filled with incredibly thin gas, so thin that it's almost impossible to detect with traditional telescopes. But this gas isn't completely invisible. When light from distant quasars passes through it, the gas absorbs certain wavelengths, leaving behind faint fingerprints in the form of absorption lines. By studying these lines, scientists have been able to infer the presence of some of the missing baryons. However, this still doesn't account for all of them. Another possibility is that the missing matter is tied up in what's called the warm-hot intergalactic medium, or WIM. This is a network of hot, ionized gas that stretches across the universe like a cosmic web. The WIM is so hot that it emits X-rays, but these signals are incredibly faint and difficult to detect. To make matters worse, the WIM is spread out over such vast distances that it's like trying to find a needle in a haystack the size of a galaxy. Despite these challenges, astronomers have made some progress, using advanced X-ray telescopes to map out small portions of this elusive structure. But even with these discoveries, the mystery persists. Some scientists speculate that the missing baryons could be hiding in other forms, such as faint dwarf galaxies or even as part of massive cosmic filaments that we haven't yet observed. Others suggest that our current methods of detection might simply be too limited to find all the missing matter. After all, the universe is a vast and complex place, and our tools are still evolving. The missing baryon problem isn't just a cosmic accounting error. It's a reminder of how much we still have to learn about the universe. It challenges us to refine our theories, develop new technologies, and think creatively about where and how we search for answers. As we continue to explore the cosmos, this mystery serves as a humbling reminder that even the most familiar aspects of the universe can still hold surprises. With this enigma still unresolved, let's turn our attention to another cosmic oddity, the Boötes Void, a vast, nearly empty region of space that defies our expectations of how the universe should look. Now, shifting our gaze to another corner of the cosmos, we encounter a region so vast and eerily empty that it challenges our understanding of the universe's structure, the Boötes Void. Imagine a space so colossal that it could fit thousands of galaxies, yet it's almost entirely devoid of them. This is the Boötes Void, a cosmic desert stretching across an astonishing 250 million light-years. To put that into perspective, if you were to travel at the speed of light, it would take you 250 million years to cross it. And yet, within this immense expanse, only a handful of galaxies have been found, making it one of the emptiest places we've ever discovered. So, why is the Boötes Void so empty? The answer lies in the way the universe evolved after the Big Bang. In the early universe, matter wasn't distributed evenly. Instead, it clumped together in some areas, forming galaxies and galaxy clusters, while other regions were left almost barren. Over billions of years, gravity pulled matter into denser regions, leaving behind vast voids like the one in Boötes. But what makes this void particularly fascinating is its sheer size. Most voids in the universe are much smaller, typically spanning tens of millions of light-years. The Boötes Void, however, is an outlier, a cosmic anomaly that defies the norm. This emptiness isn't just a curiosity. It tells us something profound about the universe's large-scale structure. The distribution of matter in the cosmos isn't random. Instead, it forms a web-like pattern with dense filaments of galaxies connected by vast, empty spaces. These voids are like the negative spaces in a cosmic painting, shaping the overall structure of the universe. The Boötes Void, as one of the largest known voids, offers a unique window into this intricate web. By studying it, scientists can better understand how gravity and dark energy have shaped the universe over billions of years. But the Boötes Void isn't just a blank canvas. Even in its emptiness, it holds clues to the universe's history. The few galaxies that do reside within the void are often isolated, with fewer neighbors than galaxies in denser regions. This isolation can affect how these galaxies evolve, offering insights into the role environment plays in galactic development. Additionally, the void's emptiness allows light from distant objects to travel through it relatively undisturbed, providing a clearer view of the universe's distant past. The Boötes Void is a reminder that the universe is full of surprises. It challenges our assumptions about how matter is distributed and forces us to rethink our models of cosmic evolution. As we continue to explore these vast, empty regions, we uncover not just the mysteries of the void itself, but also the broader story of how the universe came to be. With this enigmatic void still lingering in our minds, let's turn our attention to another cosmic puzzle, the Eridanus supervoid, a massive cold spot in the cosmic microwave background that has left scientists scratching their heads. Now, as we venture deeper into the cosmos, we encounter another baffling mystery, the Eridanus supervoid. This colossal region of space, stretching over an astonishing 1 billion light-years, is marked by an unusually cold spot in the cosmic microwave background, the faint afterglow of the Big Bang. This cold spot has puzzled scientists for decades, as it defies our expectations of how the universe should look on such a grand scale. So, what exactly is the Eridanus supervoid? Imagine a vast, almost empty region of space, so enormous that it could contain thousands of galaxies, yet it appears eerily sparse. This supervoid is one of the largest structures ever discovered, and its existence challenges our understanding of the universe's large-scale structure. The cold spot in the cosmic microwave background, which corresponds to this supervoid, is particularly intriguing because it suggests that something extraordinary is happening here, something that our current models of cosmology struggle to explain. One leading theory is that the Eridanus supervoid is a result of the universe's uneven distribution of matter. Just as the Boötes void represents a cosmic desert, the Eridanus supervoid may be an even larger and more extreme example of such emptiness. As light from the cosmic microwave background travels through this void, it loses energy, a phenomenon known as the integrated Sachs-Wolf effect. This energy loss could explain why the region appears colder than its surroundings. However, the sheer size of the supervoid makes this explanation incomplete, as the observed cold spot is far more pronounced than what current models predict. This discrepancy has led to more speculative theories, including the possibility that the Eridanus supervoid is evidence of a collision with another universe. According to this idea, our universe might not be alone. Instead, it could be part of a multiverse where other universes exist alongside ours. If another universe collided with ours in the distant past, it could have left behind a massive void like the Eridanus supervoid as a kind of cosmic scar. While this theory is highly speculative, it highlights how much we still have to learn about the nature of reality. The Eridanus supervoid also raises questions about the role of dark energy in shaping the universe. Dark energy, the mysterious force driving the accelerated expansion of the cosmos, could be influencing the growth of such voids over billions of years. By studying the supervoid, scientists hope to gain insights into how dark energy interacts with the universe's large-scale structure and whether it plays a role in creating these vast, empty regions. What makes the Eridanus supervoid so fascinating is not just its size or its cold spot, but what it represents, a challenge to our understanding of the cosmos. It reminds us that the universe is full of surprises, and even our most advanced theories can't yet explain everything we observe. As we continue to explore these cosmic anomalies, we edge closer to unraveling the mysteries of the universe's origins and its ultimate fate. With the Eridanus supervoid still lingering in our thoughts, let's turn our attention to another cosmic enigma, the Kuiper Belt Cliff, a sudden drop-off in objects at the edge of our solar system that has left scientists searching for answers. Now, shifting our gaze closer to home, we encounter a mystery lurking at the edge of our own solar system, the Kuiper Belt Cliff. This strange phenomenon refers to a sudden and dramatic drop-off in the number of objects observed in the outer reaches of the Kuiper Belt, a vast region of icy bodies beyond Neptune. It's as if the Kuiper Belt, which is already a treasure trove of comets, dwarf planets, and other remnants from the solar system's formation, abruptly ends, leaving scientists puzzled about what lies beyond. The Kuiper Belt is often compared to a cosmic junkyard, filled with debris left over from the early days of our solar system. But unlike the asteroid belt between Mars and Jupiter, the Kuiper Belt is far larger and more dynamic. It's home to famous objects like Pluto and Eris, as well as countless smaller bodies. Yet, as we venture farther out, the number of these objects drops off sharply, creating what scientists call the Kuiper Belt Cliff. This sudden decrease is unexpected, as our models predict a more gradual decline in the number of objects as we move away from the Sun. So, what could be causing this abrupt boundary? One leading theory suggests the presence of an undiscovered planet, often referred to as Planet 9. This hypothetical world, thought to be several times the mass of Earth, could be lurking in the distant reaches of the solar system, its gravitational influence sculpting the Kuiper Belt and creating the observed cliff. If Planet 9 exists, its gravity could have swept up or ejected objects from the outer Kuiper Belt, leaving behind a noticeable gap. While no direct evidence of Planet 9 has been found yet, its potential existence continues to fuel speculation and ongoing searches. Another possibility is that the Kuiper Belt Cliff is the result of a passing star. Billions of years ago, during the early days of the solar system, a nearby star might have come close enough to disrupt the outer Kuiper belt. This stellar encounter could have pulled objects away, creating the sharp drop-off we see today. While this idea is harder to prove, it highlights how interactions with other stars could have shaped our solar system in ways we're only beginning to understand. The Kuiper Belt Cliff also raises questions about the formation and evolution of our solar system. If the outer edge of the Kuiper Belt is indeed shaped by an unseen planet or a long-ago stellar encounter, it could provide clues about the chaotic environment in which our solar system was born. Studying this region could help us piece together the history of how planets and other bodies formed and migrated over billions of years. What makes the Kuiper Belt Cliff so intriguing is that it challenges our understanding of the solar system's boundaries. It reminds us that even in our own cosmic backyard, there are still mysteries waiting to be solved. As we continue to explore this distant frontier, we may uncover answers that reshape our understanding of the solar system's past and perhaps even its future. With the Kuiper Belt Cliff still sparking curiosity, let's turn our attention to another cosmic puzzle, the Moon's ancient magnetic field, a phenomenon that once rivaled Earth's but mysteriously vanished billions of years ago. Now, let's journey closer to home and explore a mystery that once shaped our closest celestial neighbor, the Moon's ancient magnetic field. Today, the Moon is a quiet, airless world with no global magnetic field to speak of. But billions of years ago, it was a very different story. Scientists believe the Moon once had a magnetic field as strong as Earth's, a force powerful enough to shield its surface from solar radiation and cosmic rays. Yet, this magnetic shield vanished long ago, leaving behind a puzzle that continues to intrigue researchers. So, how did the Moon generate such a strong magnetic field in the first place? On Earth, our magnetic field is powered by the churning of molten iron in the planet's core, a process known as the dynamo effect. For the Moon to have had a similar field, it would have needed a molten core and the right conditions to sustain a dynamo. But the Moon is much smaller than Earth, and its core would have cooled faster. This raises the question what kept the Moon's core hot and active long enough to generate such a powerful magnetic field. One theory suggests that the Moon's early magnetic field was fueled by its unique relationship with Earth. During its formation, the Moon was much closer to our planet, and the gravitational forces between the two bodies could have created intense tidal heating. This heating might have kept the Moon's core molten, allowing it to generate a magnetic field. Over time, as the Moon drifted farther away from Earth, this tidal heating would have diminished, causing the core to cool and the magnetic field to fade. Another possibility is that the Moon's magnetic field was driven by impacts. In its early history, the Moon was bombarded by massive asteroids and comets, which could have stirred up its interior and temporarily reignited its dynamo. These impacts might have provided the energy needed to sustain a magnetic field for a time, but as the bombardment slowed, so too would the Moon's magnetic activity. The disappearance of the Moon's magnetic field also raises questions about its surface. Without a protective magnetic shield, the Moon became exposed to the full force of solar wind and cosmic radiation. This exposure likely played a role in shaping the Moon's barren, cratered landscape and may have even influenced the formation of its unique regolith, the layer of dust and broken rock that covers its surface. Understanding the Moon's ancient magnetic field isn't just about solving a cosmic mystery, it's also about piecing together the history of our solar system. By studying lunar rocks brought back by Apollo missions, scientists have found evidence of this long-lost magnetic field, preserved in tiny magnetic minerals. These clues are helping researchers reconstruct the Moon's past and shed light on how other small planetary bodies might have behaved in their early days. The Moon's magnetic field is a reminder that even familiar objects in our night sky hold secrets waiting to be uncovered. As we continue to explore our lunar neighbor, we may find answers that not only explain its past but also deepen our understanding of planetary evolution across the cosmos. With the moon's magnetic mystery still lingering, let's turn our attention to another enigmatic event, the Tunguska explosion, a cosmic blast that flattened a vast swath of Siberian forest over a century ago, leaving behind more questions than answers. Now, shifting our gaze from the moon to Earth, we encounter one of the most dramatic cosmic mysteries in recorded history, the Tunguska event. On the morning of June 30th, 1908, a massive explosion rocked the remote forests of Siberia near the Tunguska River. The blast was so powerful that it flattened an estimated 2,000 square kilometers of forest, snapping trees like matchsticks and sending shockwaves that were felt hundreds of kilometers away. Eyewitnesses described a blinding light streaking across the sky, followed by a deafening roar and a heat so intense it felt like the world was on fire. Yet, despite the devastation, no impact crater was ever found, leaving scientists puzzled for over a century. So, what caused this colossal explosion? The leading theory points to a cosmic intruder, a comet or asteroid entering Earth's atmosphere. If a stony asteroid or icy comet fragment exploded in the air before hitting the ground, it could have released an immense amount of energy without leaving a crater. This phenomenon, known as an airburst, would explain the widespread destruction and the absence of a crater. The energy released by the Tunguska event is estimated to have been equivalent to 10 to 15 megatons of TNT, making it hundreds of times more powerful than the atomic bomb dropped on Hiroshima. But the mystery doesn't end there. If it was a comet or asteroid, why haven't we found any fragments? Some researchers suggest that the object was composed of fragile material, like ice or loosely packed rock, which disintegrated completely upon entering the atmosphere. Others propose that the explosion vaporized the object entirely, leaving no trace behind. This lack of physical evidence has fueled alternative theories, including more exotic explanations like a small black hole passing through Earth or even an alien spacecraft exploding in the atmosphere. While these ideas are intriguing, they remain speculative, with most scientists favoring the comet or asteroid hypothesis. The Tunguska event also raises questions about our planet's vulnerability to cosmic impacts. If a similar explosion were to occur over a populated area today, the consequences would be catastrophic. This realization has spurred efforts to track near-Earth objects and develop strategies to mitigate potential threats. The Tunguska event serves as a stark reminder of the power of cosmic forces and the importance of understanding them. As we piece together the clues from this enigmatic event, one thing is clear. The Tunguska explosion is a testament to the unpredictability of our universe. Whether it was a comet, an asteroid, or something even more mysterious, the Tunguska event continues to captivate scientists and enthusiasts alike, reminding us that Earth is not immune to the wonders and dangers of the cosmos. With the Tunguska mystery still echoing through the ages, let's turn our attention to another celestial glow that has puzzled astronomers for centuries, the zodiacal light, a faint, mysterious radiance that lights up the night sky. Now, let's shift our focus to a more subtle yet equally fascinating cosmic mystery, the zodiacal light. This ethereal glow, often described as a faint, triangular radiance stretching upward from the horizon, has captivated skywatchers for centuries. Visible just before dawn or after dusk, the zodiacal light is caused by sunlight reflecting off countless tiny particles of cosmic dust scattered throughout the inner solar system. But despite its beauty, this phenomenon remains shrouded in mystery, leaving astronomers with more questions than answers. So, where does this cosmic dust come from? The leading theory suggests that it's the debris left behind by comets and asteroids as they travel through the solar system. As these objects pass near the sun, they shed dust and ice, creating a vast, diffuse cloud that orbits our star. Over time, this dust accumulates along the plane of the solar system, forming what's known as the zodiacal cloud. When sunlight hits these particles, it scatters, creating the soft glow we see from Earth. But here's the puzzling part: scientists still don't fully understand how this dust is distributed or why it behaves the way it does. One of the biggest challenges in studying the zodiacal light is its faintness. Unlike other cosmic phenomena, it doesn't emit its own light, making it difficult to observe in detail. Even with advanced telescopes, astronomers struggle to map the exact distribution of the dust or determine its precise composition. Some researchers have proposed that the dust might be replenished by collisions between asteroids or by the constant stream of particles ejected from comets. Others suggest that interstellar dust drifting into our solar system from beyond could also play a role. Yet, despite decades of research, the true origin and dynamics of this dust remain elusive. Adding to the mystery is the fact that the zodiacal light isn't uniform. Observations have revealed subtle variations in its brightness and structure, hinting at complex interactions between the dust and the solar wind, the stream of charged particles flowing from the sun. Some scientists believe that these interactions could cause the dust to clump together or disperse in unexpected ways, creating patterns that we're only beginning to detect. But without more data, these ideas remain speculative. The zodiacal light also raises questions about the history of our solar system. By studying this dust, astronomers hope to uncover clues about the formation and evolution of planets, comets, and asteroids. Some even speculate that the dust could hold traces of ancient materials from the early solar system, offering a glimpse into the conditions that existed billions of years ago. Yet for now, the zodiacal light remains a tantalizing enigma, a reminder of how much we still have to learn about the cosmos. As we marvel at this celestial glow, let's turn our attention to another cosmic puzzle that challenges our understanding of the universe: the Hubble tension, a discrepancy in measurements of the universe's expansion rate that has left scientists scratching their heads. Now, let's dive into one of the most perplexing challenges in modern cosmology: the Hubble tension. This mystery revolves around a puzzling discrepancy in how fast the universe is expanding, a fundamental measurement that shapes our understanding of the cosmos. For decades, scientists have relied on two primary methods to calculate the universe's expansion rate, often referred to as the Hubble constant. The first method involves studying nearby objects such as Cepheid variable stars and supernova to measure distances and velocities. The second method looks at the cosmic microwave background, the faint afterglow of the Big Bang, to infer the expansion rate from the early universe. Here's where things get interesting. These two methods, despite being incredibly precise, give different results. And this inconsistency, known as the Hubble tension, has left astronomers scratching their heads. The implications of this discrepancy are profound. If the universe is expanding faster than we thought, it could mean that our understanding of dark energy, the mysterious force driving the acceleration, is incomplete. Alternatively, it might suggest that there's something missing in our models of the early universe or even in the laws of physics themselves. Some scientists have proposed that new, unknown particles or forces could be at play, subtly influencing the expansion rate. Others speculate that systematic errors in our measurements might be to blame, though extensive checks have so far failed to resolve the tension. Whatever the cause, the Hubble tension is forcing us to rethink some of the most fundamental aspects of cosmology. One potential solution lies in refining our observational techniques. For instance, upcoming missions like the James Webb Space Telescope aim to provide even more precise measurements of distant stars and galaxies, potentially narrowing the gap between the two methods. Another approach involves re-examining the assumptions built into our cosmological models. Could there be an overlooked factor, such as an unexpected interaction between dark matter and dark energy, that's throwing off our calculations? Some researchers are even exploring the possibility that the Hubble tension hints at a deeper truth, that our universe isn't as uniform as we once thought, and that local variations in expansion rates might be skewing our measurements. As we grapple with this cosmic puzzle, it's worth reflecting on what the Hubble tension tells us about the nature of science itself. Sometimes the most profound discoveries come not from confirming what we already know, but from uncovering the gaps in our knowledge. The Hubble tension is a reminder that the universe is full of surprises, and that even our best theories are works in progress. With every new observation and every refined model, we inch closer to unraveling this mystery and perhaps uncovering new ones along the way. As we ponder the implications of the Hubble tension, let's turn our attention to another enigmatic phenomenon that continues to baffle scientists: the galactic center excess, an unexplained burst of gamma-ray radiation emanating from the heart of our Milky Way. Shifting our gaze to the heart of our galaxy, we encounter another cosmic puzzle: the galactic center excess. This mysterious phenomenon refers to an unexpected surge of gamma-ray radiation emanating from the center of the Milky Way. Gamma rays are the most energetic form of light, and their presence in such abundance near the galactic core has left scientists both intrigued and perplexed. The first clues to this mystery emerged when astronomers analyzed data from the Fermi Gamma-ray Space Telescope. They noticed a significant excess of gamma rays that couldn't be explained by known sources, such as supernova remnants or pulsars. This excess radiation forms a diffuse glow concentrated around the galactic center, and its origin remains one of the most debated topics in astrophysics. One leading theory suggests that the gamma rays could be the result of dark matter annihilation. Dark matter, the invisible substance that makes up most of the universe's mass, is thought to clump densely at the center of galaxies. If dark matter particles collide and annihilate each other, they could produce gamma rays as a byproduct. This idea is tantalizing because it could provide the first direct evidence of dark matter's existence. However, despite extensive research, no definitive proof has been found to confirm this hypothesis. Another possibility is that the gamma rays come from a population of rapidly spinning neutron stars, known as millisecond pulsars, clustered near the galactic center. These incredibly dense objects emit powerful beams of radiation as they rotate, which could collectively produce the observed gamma-ray excess. Yet, identifying these pulsars has proven challenging, as they are faint and difficult to detect amidst the crowded stellar environment of the galactic core. Adding to the complexity, some researchers propose that the excess could be caused by a combination of factors, including cosmic rays interacting with gas clouds or even unknown astrophysical processes. Each theory has its strengths and weaknesses, and so far, none have been able to fully explain the observations. What makes the galactic center excess so fascinating is that it sits at the intersection of multiple cosmic mysteries: dark matter, pulsars, and the dynamic environment of the galactic center. It's a reminder that even our own galaxy holds secrets we have yet to unravel. As astronomers continue to refine their observations and develop new models, this enigmatic glow may eventually reveal deeper truths about the universe. With the galactic center excess still shrouded in mystery, let's now turn our attention to another intriguing hypothesis that could reshape our understanding of the solar system: the Planet 9 hypothesis. Moving from the mysteries at the heart of our galaxy, we now venture closer to home, where another cosmic enigma awaits: the Planet 9 hypothesis. This idea suggests that somewhere in the distant reaches of our solar system, beyond the orbit of Neptune, a massive, undiscovered planet might be lurking. While we've long considered Pluto the ninth planet, its reclassification as a dwarf planet in 2006 left a gap in our planetary lineup. Could there truly be another world out there waiting to be found? The story of Planet 9 begins with a peculiar pattern in the orbits of distant icy objects in the Kuiper Belt, a region beyond Neptune filled with small, frozen bodies. Astronomers noticed that some of these objects have orbits that are oddly aligned, as if something large and unseen is tugging on them. This gravitational influence hints at the presence of a planet far more massive than Earth, possibly 10 times its size, with an orbit so vast it could take between 10,000 and 20,000 years to complete a single trip around the Sun. But if such a planet exists, why haven't we seen it yet? The answer lies in its distance and darkness. Planet 9, if it's out there, would be incredibly far from the Sun, anywhere from 300 to 600 times farther than Earth. At such a distance, sunlight barely reaches it, making it nearly invisible to our telescopes. Even the most advanced instruments struggle to detect an object so faint and so far away. It's like trying to spot a single candle flame in a vast, dark forest. The search for Planet 9 has sparked a mix of excitement and skepticism in the scientific community. Some researchers argue that the gravitational anomalies could be explained by other factors, such as a cluster of smaller objects or even a primordial black hole. However, the Planet 9 hypothesis remains one of the most compelling explanations for the strange behavior of these distant Kuiper belt objects. What makes this mystery so captivating is the possibility of rewriting our understanding of the solar system. Discovering Planet 9 wouldn't just add another planet to our list, it would challenge our assumptions about how planetary systems form and evolve. It's a reminder that even in our own cosmic backyard, there are still secrets waiting to be uncovered. As we ponder the existence of this elusive world, let's shift our focus to another cosmic puzzle that defies explanation: the origin of ultra-high-energy cosmic rays. Now, let's turn our attention to a phenomenon that pushes the boundaries of our understanding of physics: the mystery of ultra-high-energy cosmic rays. These are not your ordinary cosmic rays. They are particles traveling through space at energies so immense that they defy everything we know about how the universe works. Imagine a single particle carrying as much energy as a fast-pitched baseball, but packed into something smaller than an atom. That's the kind of power we're talking about. So, where do these ultra-high-energy cosmic rays come from? That's the million-dollar question. Scientists have been trying to pinpoint their origins for decades, but it's no easy task. These particles are so energetic that they shouldn't even exist according to our current understanding of physics. They're thought to come from some of the most extreme environments in the universe, places like supermassive black holes, exploding stars, or even colliding galaxies. Yet, despite their incredible energy, tracing them back to their source is like trying to follow a single raindrop in a thunderstorm. One of the biggest challenges is that these cosmic rays don't travel in straight lines. As they zip through space, they interact with magnetic fields which bend their paths and make it nearly impossible to track where they started. It's like trying to follow a winding river without knowing where it begins. To make matters worse, these particles are incredibly rare. Detecting them requires massive observatories like the Pierre Auger Observatory in Argentina, which covers an area the size of Rhode Island just to catch a handful of these elusive particles. The mystery deepens when we consider that some of these cosmic rays have energies so high that they shouldn't be able to travel long distances without losing energy. Yet here they are, reaching Earth from billions of light years away. This has led scientists to propose some wild theories, including the possibility of new physics beyond the standard model, or even exotic objects like cosmic strings, hypothetical defects in the fabric of spacetime. What makes this mystery so fascinating is that it challenges our understanding of the universe on a fundamental level. Solving it could unlock secrets about the most violent and energetic processes in the cosmos, or even reveal entirely new laws of physics. For now, ultra-high-energy cosmic rays remain one of the most tantalizing puzzles in modern astronomy, a reminder that the universe still holds many surprises. As we grapple with the mysteries of these high-energy particles, let's shift our gaze to another cosmic oddity: the strange alignment of quasars across billions of light years. Now, let's journey into another cosmic enigma that has left astronomers scratching their heads: the peculiar alignment of quasars across unimaginable distances. Quasars, the brightest objects in the universe, are powered by supermassive black holes at the centers of galaxies, devouring matter and spewing out intense radiation. But here's the twist. When scientists mapped the positions of these quasars, they noticed something bizarre. Over billions of light years, their rotation axes appeared to align in a way that defies randomness. It's as if some unseen force is orchestrating their orientation on a cosmic scale. This discovery challenges our understanding of the universe's large-scale structure. According to the standard model of cosmology, matter should be distributed more or less uniformly with no preferred direction. Yet, the alignment of quasars suggests there might be a hidden pattern or structure woven into the fabric of the cosmos. Some researchers propose that this alignment could be evidence of cosmic strings hypothetical, one-dimensional defects in space-time left over from the early universe. Others suggest it might hint at the influence of dark energy or even a previously unknown force shaping the universe on the grandest scales. What makes this phenomenon so intriguing is its sheer scale. The alignment spans distances so vast that it would take light billions of years to travel from one end to the other. This raises profound questions about how such a pattern could form and persist over such enormous scales. Is it a relic of the universe's infancy, a clue to the conditions that existed just after the Big Bang? Or is it a sign of something even more fundamental that we've yet to uncover? The implications are staggering. If this alignment is real and not just a statistical fluke, it could force us to rethink our models of the universe's evolution. It might even point to new physics, offering a glimpse into the forces that govern the cosmos on the largest scales. For now, the quasar alignment remains one of the most tantalizing mysteries in modern astronomy, a cosmic puzzle that reminds us just how much we still have to learn about the universe. As we ponder the mysteries of these aligned quasars, let's turn our attention to another celestial wonder, the Red Rectangle Nebula, a cosmic gem that stands out for its unique shape and vibrant colors. Now, shifting our gaze to a cosmic masterpiece that defies the ordinary, we encounter the Red Rectangle Nebula, a celestial phenomenon that captivates with its striking geometry and vivid hues. Unlike the chaotic swirls of many nebulae, this one boasts a near-perfect rectangular shape, earning it its distinctive name. Located about 2,300 light-years away in the constellation Monoceros, the Red Rectangle Nebula is a planetary nebula, the glowing remains of a dying star. But what makes it truly extraordinary is its symmetry and the deep red color that dominates its appearance. The red rectangle's unique shape is thought to be the result of a binary star system at its core. As the primary star neared the end of its life, it expelled its outer layers, creating a dense disk of gas and dust. The gravitational influence of the companion star then sculpted this material into the nebula's rectangular form. This intricate dance between the two stars has produced a structure that is both rare and mesmerizing, standing out even among the diverse array of planetary nebulae. Adding to its allure is the nebula's vibrant red color, which comes from a process called fluorescence. Ultraviolet light from the central star excites hydrogen molecules in the surrounding gas, causing them to emit a reddish glow. This phenomenon, combined with the nebula's geometric perfection, makes it a favorite subject for astronomers and astrophotographers alike. But the Red Rectangle Nebula isn't just a pretty sight, it's also a cosmic laboratory. Its unusual structure provides valuable insights into the final stages of stellar evolution and the complex interactions within binary star systems. By studying this nebula, scientists hope to better understand how stars like our Sun might end their lives and how their remnants shape the cosmos. As we marvel at the Red Rectangle's beauty and mystery, let's turn our attention to one final cosmic puzzle, the universe's missing lithium, a discrepancy that challenges our understanding of the Big Bang itself. Now, as we delve into one of the most perplexing puzzles in cosmology, we encounter the universe's missing lithium, a mystery that strikes at the very heart of our understanding of the Big Bang. According to the widely accepted model of the universe's origins, the Big Bang should have produced specific amounts of light elements, including hydrogen, helium, and lithium. While hydrogen and helium match predictions almost perfectly, lithium presents a glaring discrepancy. Observations show that there's only about 1/3 of the lithium in the universe that the Big Bang theory suggests should exist. This missing lithium has left scientists scratching their heads for decades. So, why does this matter? Lithium is one of the 3 elements forged in the first few minutes after the Big Bang, making it a crucial piece of evidence for understanding the universe's earliest moments. The fact that we're not seeing the expected amount challenges the accuracy of our models and raises questions about what we might be missing. Could there be errors in our calculations? Or is there some unknown process at work, destroying or hiding lithium over billions of years? One possibility is that lithium is being consumed or transformed in ways we don't yet understand. Stars, for example, are known to burn lithium as fuel, but this alone doesn't account for the massive shortfall. Another theory suggests that lithium might be locked away in regions of space that are difficult to observe, such as the interiors of ancient stars or diffuse clouds of gas. Yet, despite extensive searches, astronomers haven't found enough lithium to close the gap. This lithium problem isn't just a minor hiccup, it's a fundamental challenge to our understanding of the cosmos. If our models of the Big Bang are incomplete or incorrect, it could mean rethinking some of the most basic principles of physics and cosmology. The missing lithium serves as a reminder that even our most well-established theories are still works in progress, and the universe always has more secrets to reveal. As we wrap up our journey through these 25 cosmic mysteries, it's clear that the universe is far more enigmatic than we often realize. From dark matter to the missing lithium, each phenomenon reminds us of how much we have yet to discover. Which of these mysteries fascinates you the most? Let us know in the comments below, and don't forget to subscribe for more deep dives into the wonders of space. Thanks for watching, and until next time, keep looking up. As we bring our exploration of these 25 cosmic mysteries to a close, it's impossible not to feel a sense of awe at just how much we still don't know about the universe. From the invisible grip of dark matter to the baffling absence of lithium, each phenomenon we've discussed serves as a humbling reminder of the vastness of the cosmos and the limits of our current understanding. These mysteries aren't just scientific puzzles, they're invitations to keep exploring, questioning, and marveling at the wonders that lie beyond our reach. Think about it, every time we uncover one secret, the universe seems to reveal 10 more. Whether it's the strange alignment of quasars across billions of light years or the unexplained gamma rays emanating from the heart of our galaxy, these enigmas challenge us to rethink what we know and push the boundaries of human knowledge. And that's what makes space so endlessly fascinating. It's a frontier that never stops surprising us. So, which of these cosmic mysteries captured your imagination the most? Was it the eerie silence of the Fermi Paradox, the strange behavior of Oumuamua, or the mind-bending implications of the black hole information paradox? Let us know in the comments below. We'd love to hear your thoughts and theories. And if you enjoyed this journey through the unknown, don't forget to hit that subscribe button and ring the notification bell so you never miss out on our next deep dive into the mysteries of space. Thanks for joining us on this cosmic adventure, and remember, the universe is full of secrets waiting to be discovered. Until next time, keep looking up.